Today we're going to learn how to divide mixed numbers. If you've been with us in previous lessons, we've been working on dividing fractions using a few different strategies, including bar models, skip, flip, multiply, and keep, change, flip. If you haven't been with us, make sure to subscribe for the latest videos and check out the links in the video description. All right, so if you're following along in your workbook, we're in chapter 2, dealing with mixed numbers, dividing with mixed numbers. And our focus really here is that every mixed number is just an improper fraction in disguise. And so making that conversion is what really helps us master dividing mixed numbers. So let's take a moment and think about this here. When learning to convert mixed numbers into improper fractions, it's important that we go beyond simply memorizing the steps, like multiply the whole number by the denominator, add the numerator, and keep the denominator. There are so many steps that we lose track of what we're doing and why we're doing it. While those steps are useful, they won't stick with us for long if we don't understand why we're doing them. Without making sense of the process, right, we're likely to forget the procedure altogether. True learning happens when we not only know how to solve a problem, but also why it works. So let's make sense of converting mixed numbers to improper fractions by connecting it to what we've already learned in the previous chapter about fractions representing how many parts make up a whole. Our first goal today is to review how to convert a mixed number into an improper fraction. Remember that a mixed number would be like 2 1/3, and we want to rewrite it as an improper fraction to make the math more simple as we divide. Next, we will do a couple examples where we divide a mixed number by a fraction. And with our third and final goal, we're going to divide a mixed number by a mixed number. Remember that a mixed number is exactly what it sounds like, a mixed number. It has a mix of a whole number and a fraction representing one total amount. It is part of a whole amount written with a numerator and a denominator. An example is 2 3/4. It's mixed. 2 is the whole number, 3/4 is the fraction, but it's one total amount, 2 3/4. Next, we have a numerator. This is the number above the line in a fraction. It's the number on the top that's showing how many parts are indicated by the denominator or taken. Remember, a fraction is a part to whole comparison, so the numerator is the part that you get. Next, we have the denominator, and this is the number on the bottom. It's the number below the line of the common fraction, and it's actually the divisor. Remember that all fractions are division problems, so the bottom number, the denominator, is also the divisor. Here we have an example for both, 5/7. The numerator is 5, the number on the top, and the denominator is 7, the number on the bottom. Our next vocabulary word is an improper fraction. Now, an improper fraction is a fraction whose amount is greater than 1, and it's where the numerator is bigger than the denominator. That's what makes the value greater than 1. So an example of an improper fraction is 9/4. The 9, the numerator, is bigger than the 4. It makes it improper. We know that that amount is greater than 1. It's actually the same value as the mixed number 2 1/4. But as an improper fraction, we write it as 9/4. Okay, so let's get into it. We are looking at converting mixed numbers into improper fractions so that we can divide mixed numbers by a fraction. So if we're starting right here with our first problem, we're looking at 2 3/4 divided by a fourth. And remember, we want to think to ourselves, how many pieces of a fourth fit into this amount? Again, we're going to be using a bar model. And right here you see we have 1, 2, 3 bars, right? And it's representing 2, 1, 2, and 3/4. So we're going to shade in 3 out of the 4 in our last bar. So 2 3/4 is this visual representation. And then I'm asking myself, how many 1/4s, okay, how one 1/4s fit into this amount? And so if we go through and count them, as you can see here, okay, this is a fourth, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 2 3/4, which is what we started with here in the blue, we had 2 3/4 if we divided that by a fourth, we wanted to know how many fourths fit in to 2 3/4, and we counted up that there was 11 fourths total. So our answer is 11. Okay, now we could check this if we want to check it with keep, change, flip, or skip, flip, multiply. We're going to check that next right here. So we just looked at why it works, right? We used our bar model to see that there were 11 fourths in 2 3/4. And now right here, we're going to look at 2 3/4 and we're going to divide it out. So this mixed number, a lot of people will refer to converting a mixed number to an improper fraction by saying around the world. So you start with your denominator here, which is 4, and you're going to do 4 times 2, which gives you 8, and then you're going to add 8 plus 3, which gives you 11. The denominator stays the same, 11 fourths. Also, remember up here, we had 2 3/4. And when we counted it out, there were 11 fourths total. So we see how this visual representation is showing us the same amount here, 11 fourths. And so then now we have 11 fourths divided by 1/4. So 11 fourths divided by 1/4. If we are going to do keep, change, flip, we keep the first term, 11 fourths. We're going to change division into multiplication, and then we're going to take the reciprocal of 1/4, which is flipping the fraction from the numerator to the denominator and the denominator to the numerator. And that is how we get 11 fourths times 4/1. Okay, so when we multiply fractions, we do top times top, bottom times bottom. 11 times 4 gives us 44. My pen is being little wonky. 44, and then 4 times 1 is 4. 44 divided by 4 equals 11, and that's our answer. So this is how it works when we do a mixed number divided by a fraction, but this is why it works. When you can visually see, we're thinking about how many fourths fit into 2 3/4. Okay, we're going to do a couple problems together. We're going to be dividing a mixed number by a fraction. Find the quotient for each problem. Remember that quotient means the answer to a division problem. And for today, we're going to do number 1, and I'm going to have you try number 2, and then I'll go over the answer. So let's look at number 1. We have 3½ divided by 1/2. And for these problems, we are going to convert our mixed number into an improper fraction first, and then we are going to use keep, change, flip, okay, to find our answer. You can also use a bar model if you would like to visually make sense of the math. So we start with our denominator 2. 2 times 3 gives us 6, and then we have 2 times 3 gives us 6, and then we're going to do 6 plus 1 gives us 7/2. Okay, remember this would look like if I had 3 full bars and half of a bar. If I had 3 whole bars and all of my bars were cut into halves, right, I would have 1, 2, 3, 4, 5, 6, 7/2. So 7/2 is the same amount, same thing as 3½. So we have 7/2 divided by 1/2. So we're going to use keep, change, flip. We're going to keep 7/2 the same. We're going to change division to multiplication, and then we're going to flip 1/2 to 2/1, or take the reciprocal of 1/2. And then now when we multiply fractions, we do top times top, bottom times bottom. 7 times 2 gives me 14, and 2 times 1 equals 2. Remember, all fractions are division problems. This is the same as 14 divided by 2. 14/2 equals 7. And my answer is 7. Okay, why don't you go ahead and give it a try? If you'd like, you can go ahead and hit the pause button right now if you want. Pause the video and try 1 3/4 divided by 7/8, and we'll come back and do it together. All right, let's see how you did. So 4 times 4 gives us 16, and then 16 plus 1 is 17, so we have 17 fourths, and I'm dividing. I have 2 times 2 is 4, I multiply, and then I'm going to add. 4 plus 1 is 5, so 2.5 is the same as 5/2. Okay, now I'm going to use keep, change, flip. So I have 17 fourths. I keep the first term as the same. I'm going to change division into multiplication, and then I'm going to flip. The 2 is going to go into the numerator, and the 5 is going to go into the denominator. That's also called the reciprocal. And then we're going to do top times top, bottom times bottom. And real quick, before I multiply, I am going to simplify before I multiply. Okay, and I know that 2, okay, goes into 4 2 times, and 2 divided by 2 is 1. And that will help make my math more simple. So I have 17 times 1 is 17, and then 2 times 5 is 10. So my answer is 17 tenths, okay, or you can rewrite your answer as a mixed number. So how many times does 17 go into 10? It goes in 1 with 7 left over. So my answer is 1 7/10, or 17 tenths. All right, so now let's remember that part of being mathematicians and learning not only the how and the why is we want to be able to apply it to real life. So let's look at this scenario, the cake slicing situation. Okay, if a bakery has 4.5 cakes left, each customer gets 3/4 of a cake. How many customers can be served? So when we have a word problem, I always like to highlight, if I can get my highlighter to click. There we go. Okay, the important information. So I know that we have 4.5 cakes left, and each right, per one customer gets 3/4 of a cake. And I'm asking how many customers, okay, can I serve? So I love with word problems to make a visual representation so I can see what they're asking. So a bakery has 4 cakes, and I'm just going to use my bar models. I love sheet pan cake for fractions. So 4 1/2. They only have 1/2 of the cakes, but 4 whole cakes and 1/2 of a cake left. Okay, somebody else ate this piece of cake right here. If each customer is going to get 3/4 of a cake, so the way, remember, the denominator is telling me how many pieces I have total, or how many slices I have total in my cake. So it's saying I have 4 slices per cake. And then each customer is getting 3. So wow, they're getting a lot of cake. So first let's take our 4.5 cakes and make sure that they're cut into 4 slices total. So if I make 3 dashes, it will get me 4 slices of cake. 1, 2, 3. Okay, and then I'm going to count how many cakes I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18/4 of a cake, but that's not what it's asking me, right? It's asking how many does each customer can they be served if I give them 3 each. Okay, so one customer gets all 3 of these. 1, 2, 3. Okay, then my next customer gets all 3 of these. So that's 3 customers. 4 customers, okay, and then now I'm going to count what I have left. I have 1, 2, 3, so there's another 3/4, so that gives me 5 customers right there, this group of slices, 5 customers, and then I have 1, 2, 3 for my last group of 3/4, so I have 6 customers total can be served. Today you learned how to divide mixed numbers. We looked first at taking a mixed number and converting it into an improper fraction using around the world. If you need more help with this, or you would like a more detailed lesson, check out the link in the video descriptions. And then we also did some examples. We did some practice with a mixed number divided by a fraction and some mixed numbers divided by mixed numbers. Remember, math isn't just about numbers, it's about mindset. Learning how to divide mixed numbers by mixed numbers might have felt like a lot at first, but every step you took built your understanding. Each time you tried, checked your work, and adjusted, you strengthened your problem solving muscles. It's okay if it didn't click all right away. That's part of learning. What matters most is that you showed up and put in the effort. Every time you practice, you're getting closer to mastery. So pause for a second and celebrate that. You're doing the work, and that's where success starts. Math is a journey, and each problem you solve is one step forward. Keep believing in yourself, keep practicing, and remember, you've got it, you've got this, and you've got what it takes to be a math marvel. Want more fraction help? Subscribe to Math Marvel Mentor for new tutorials every week. And if this made fractions click for you, share it with someone else who's struggling. Thanks for watching.